Use integration by parts to find the exact value of the integral from 0 to 2 of x multiplied by 2 to the power x with respect to x, giving your answer as a single simplified fraction. So using integration by parts here, I'm going to let u be my x and I'm going to let v dash be my 2 to the power x. So I could then use the integration by parts formula, which is uv minus the integral of u dash v. So let's let u be x and we'll let v dash be 2 to the power x. Differentiating the u function, differentiating x, I get 1. Integrating 2 to the power x, this is a bit tricky. You might not have seen this before, but we'll get 2 to the power x divided by ln2. Let me just explain that a little bit. We know that when we differentiate a function a to the power x, when I differentiate this, I get a to the power x ln a. So basically, to differentiate the a to the power x function, I multiply it by ln a. Therefore, to integrate the a to the power x function, it should be the opposite. So I'm not going to be multiplying by ln a, I'm going to be dividing by ln a. So in this case, when I'm integrating the 2 to the power x, I'm dividing it by ln2. Right, let's substitute those into our integration by parts formula then. So we've got u times v. So x times 2 to the power x over ln2 minus the integral of u dash times v. And that would be integrated with respect to x. Right, let me just try and simplify that a little bit then. So x times 2 to the power x over ln2. I've got that on the outside. Minus the integral. Now, the one obviously I don't need to worry about that. Now this ln2, that's just a number. So I can actually take that fraction, that 1 over ln2, outside of my integral. It's just a number, so I can take it outside. And that'll leave me with 2 to the power x dx on the inside of the integral. Right, let's do that second integral now. So we'll just copy that term down. We've got the 1 over ln2. And integrating the 2 to the power x dx, we've already done that. I explained that a couple of moments ago. It's just 2 to the power x over ln2. So, just simplifying all of that then. We'll get 2 to the power x. We've got the ln2 times ln2, which is ln2 squared. Right, let's substitute our limits in of 2 and 0. So substitute the 2 first, we get 2 times 2 to the power 2 over ln2 minus 2 to the power 2 over ln2 squared. Now substituting the 0 in, we'll get 0 times 2 to the power 0 over ln2 minus 2 to the power 0 over ln2 squared. Now, obviously this 0 times 2 to the power 0 is going to be 0, so we don't need to worry about that. But let's go through the rest of these. The 2 times 2 squared, so that's going to be 8. So we get 8 over ln2 minus 2 squared, so that's 4 over ln2 all squared. Then we have the minus, so we'll have a plus. The 2 to the power 0 is just 1 over ln2 squared. We can now see that these are like terms, so I can collect those together. The first term, the 8 over ln2, we'll leave that as it is for now. And yeah, let's do the minus 4 over ln2 squared plus 1 over ln2 squared is going to be minus 3 over ln2 squared. I do need to give my answer as a single simplified fraction, so I need a common denominator. So let me multiply this first fraction by ln2 so that we have a common denominator. And now I can rewrite this with a single fraction. So we'll get 8 ln2 minus 3, and that's how I'm going to leave my answer.